Chapter 14, Section 1 in the 8th grade note-taking guide is entitled Polynomials. Now, we've been working with polynomials for a while, actually, but we've been working with a very specific type of polynomial that fits into the mold of solving an equation. Now they're really going to start mixing up the polynomials by changing the degree, which is really talking about them adding exponents to said variables. When we start doing that, that really changes the look and feel of what we're studying here. So let's take a look at the terms related to polynomial. What is a polynomial? It's a monomial, or the sum or difference of monomials. Now, of course, it would be helpful if we're talking about the word monomial all of a sudden that we've also not seen to have a definition for that. A monomial is a number or a product of numbers and variables with exponents that are whole numbers. So they're saying here we can just multiply together a number and a variable, or it could just be a number, or it could just be a variable. But that's all a monomial is. It's a number or a product of numbers and variables with exponents that are whole numbers. Again, a polynomial is a monomial, or the sum or difference of monomials. So when we add together different monomials, that's going to be a polynomial. A binomial is a polynomial with two terms. A binomial is a polynomial with two terms, so one addition or subtraction sign really. Trinomial is a polynomial with three terms, so two addition or subtraction signs really. And the degree of a polynomial is the power of the term with the greatest degree. So really we're going to be looking for exponents here. Alright, so with definitions out of the way, let's go ahead and start taking a look at the examples here. Number one, we're supposed to determine whether each expression is a monomial. So number one, part A, we've got the square root of 2 times x cubed y to the 4th. Okay, so here's what you got. We're looking for, since this is a monomial, one term. So if we were to see addition or subtraction signs, you've got a problem. We don't see any addition or subtraction signs though, so we don't have any problems there. Since we don't have any problems with the addition or subtraction signs, let's look at each one and see what we've got here. Part A, you've got the square root of 2 times x cubed y to the 4th. So again, you can have a number by itself, you can have a variable by itself, or you can have the product of numbers and variables. We can be multiplying together numbers and variables. Well, as you can see here we're multiplying together a number, the square root of 2, with some variables, x cubed and y to the 4th. Well, this does fit the billing here because the definition said the exponents have to be whole numbers. 3 and 4 are whole numbers there. So, since everything fits, this is going to be a monomial. And again, primary reasoning here is because what's most important looking at this one is that the exponents are whole numbers. They don't actually have to even have exponents. It could just be x and y, and that would be okay. If we look at B, on the other hand, though, we see the same square root sign, but the problem is the square root is on y. Now, you've already learned about the square root of y this year because we've already talked about squares and square roots and how they're inverses of each other. So if I'm taking the square root of y, what I really mean is y to the 1/2 power. Well, that's a problem because remember what the billing says here, what the definition says, is that the exponents can only be whole numbers. Well, 1/2 would not be a whole number. There's nothing wrong with the 3 or the x cubed. There's nothing wrong with this being multiplication. What's the problem is this square root of y here. If the square root was on the 3, just like over here in A, it would work out fine because we'd just be multiplying together numbers and variables. But because it's the square root of y, which is the same as y to the 1/2 power, the half power is the issue here, because we cannot have an exponent that's not equal to a whole number. So here, y does not have an exponent that's a whole number, so this is not a monomial. All right, let's go ahead and take a look at number 2 here. In number 2, we're supposed to identify which each of these is based on the criteria they gave us in the definition page. So it could be a monomial, could be a binomial, could be a trinomial. If it's bigger than that, we'll just call it a polynomial, or it might not be anything at all. So remember, as you heard me say in the definitions here, all of this is based on the number of addition and subtraction signs. If you have one addition or subtraction sign, that's going to create two terms, so it's going to be a binomial. If you have two addition or subtraction signs, that's going to create three parts in your problem, so that's going to be a trinomial. If you have more than that, it's going to be a polynomial because it's going to have 4 or 5 or 6 or 7 or 8 or 9 terms. They don't really name them after that. We don't have a quadrinomial. We don't have that type of thing. So as we look at 2a here, we see that we have two variables being put together. There's nothing odd going on there with the exponents. The exponents are whole numbers, so that's good. There's no addition or subtraction signs, so since this has one term, this is a monomial. Now if we take a look at B, B does have a subtraction sign, so it has two distinct parts. So that would make it a binomial. However, if we take a look at the y here, the y has an exponent of -2. That's a problem for us because remember, as we saw in the definitions, the exponents here can only be whole numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on up. They can't be negative numbers. So even though this looks like a binomial and it would be easy to say this is a binomial, this is not anything. This is not a polynomial because it has a negative exponent. 3x to the fifth plus 2.2x squared minus 4 in part C. Well, as you can see, we have two addition and subtraction signs there, which creates three distinct parts to the problem. So that means this is a trinomial. And in part D, one addition sign creating two distinct parts there with a squared and b squared. So this is a binomial because it has two terms. All right, let's go and take a look at number 3. In number 3, they're asking me to find the degree of each polynomial. Now, the degree is simply all about the exponents on whichever part of the polynomial we want to look at. We're looking for the greatest one. The reason we talk about degrees is because when we have terms of like degree, not always, but a lot of the time we can combine them and add together or subtract, whatever the sign might be related to them. We can combine those like terms that are associated with parts of the polynomial that have the same degree, terms that have the same degree. Not always though, because for instance, I could give you an x squared and a y squared. They would both have a degree of 2. Why? Because the exponent on both of them is 2. However, since one of them is x and the other one is y, you wouldn't be able to combine them. So if we look at 3a, we're finding the degree of the polynomial x plus 4. Well, x, since it doesn't have an exponent on it, would have an exponent that's equivalent to 1. X to the first would be the same as x. The 4 part doesn't even have an exponent, no variable even, so that has a degree of 0. Because remember, it would be like if I added x to the 0th power to it, but of course anything to the 0th power is 1. 4 times 1 would still give me 4. So that's why that is what it is. So we have a degree of 1, an exponent of 1 on the first term, a degree of 0 on the second term. So the degree here is simply whatever is the greatest exponent. The greatest exponent here is 1. So the degree of x plus 4 is 1. 5x minus 2x squared plus 6. Well, first two parts are real easy. Here's x. Well, as we know from the last question, since that has no exponent, the degree there is 1. 2x squared, well, there's a stated exponent there, so the degree is 2. And then on 6 here, no exponent, so the degree is 0. So what's the greatest degree there? The greatest exponent is 2 here, so the degree of 5x minus 2x squared plus 6 is 2. The degree will also generally help me derive the number of solutions to the equation or this problem there. If it has a degree of 2, for instance, like this one, there's going to be 2 solutions when we solve it. X plus 4, When I set that equal to something, since it has a degree of 1, there's only going to be one solution to it. That's another way you can use the degree. All right, let's go and take a look at number 4 here. Number 4 says the height in feet after t seconds of a rocket launched straight up into the air from a 40-foot platform at velocity v is given by the polynomial negative 16t squared plus v times t plus 40. Find the height after 10 seconds of a rocket launched at a velocity of 275 feet per second. So luckily for us, they took that equation that was already written and rewrote it, because that's what we're going to plug into to solve. And what they said here is they want us to find the height after 10 seconds of a rocket launched at a velocity of 275. So what they want us to do is they want us to change t into 10, v into 275, and solve the polynomial. So it would just be like substituting into a simple expression, except you've got two things you're substituting here, and you've got an exponent here, because that's why it's a polynomial. It's got a degree of 2. The biggest exponent here is 2, like we saw in the last question. And you're going to solve that, and that will tell you how high the rocket is after 10 seconds when it's launched with a velocity of 275 feet per second. So I change my t's into 10s, and I change v into 275, and then I'm going to solve this using the order of operations. So I'm going to do 10 squared first, which is 100, times the negative 16, negative 1600. 275 times 10 is 2750. 40 at the end doesn't change. And then I add here, and I end up with 1190. So to solve the question, after 10 seconds, when it's launched with a velocity of 275 feet per second, the rocket is 1,190 feet high. All right, let's go ahead and take a look at the concluding examples here. Number 1, determine whether each expression is a monomial. So monomial again means one term. So remember, to be a monomial means no addition, no subtraction signs. So in looking at this one, 2w times p cubed y to the 8th, I don't see any addition or subtraction signs. That's good. So I just want to make sure it doesn't violate any of the rules. Here we all have positive number exponents here. This is a 1, this is a 3, this is an 8. There's nothing else odd going on here, so this is a monomial. It's one term. Classify as a monomial, binomial, trinomial, or not a polynomial. So 4x squared plus 7z to the 4th. So the addition sign here, one addition sign, creates two distinct parts. Since there's no violations there, we've got whole number exponents here, nothing funky going on there. This is a binomial, two terms. Find the degree of the polynomial in part 3. Again, the degree comes to us by looking at the exponents. So here on the x, the exponent is 1. Remember, if there's no number there, it's always a 1. On 4x to the 4th, the exponent is 4. On 2y, the exponent would be a 1, 1, 4, and 1. Biggest exponent is a 4, so the degree of x plus 4x to the 4th plus 2y is 4. All right, let's go ahead and take a look here at number 4, which is probably where we'll spend the most time here in this set. The height in meters after t seconds of a baseball thrown straight up into the air from s meters off the ground at a velocity v after t seconds is given by the polynomial negative 16t squared plus vt plus s. Find the height of the baseball launched from a 5-meter platform at 60 meters per second after 3 seconds. Okay, so we've got a few different numbers here that they want us to plug in. 60 meters per second, that's your velocity. So wherever I see v, I'm going to change that into 60. 3 seconds here. 3 seconds is my time, so wherever I see t, I'm going to change that into 3. And then the 5 meters, that's s. That's how high we are off the ground when we start, which is what they've described right here. So we're going to take that equation right here, plug in the numbers, and solve. So I've got negative 16 times 3 squared plus 60 times 3 plus 5. Well, of course, order of operations tells me to do this first, so it's really going to be negative 16 times 9 plus 60 times 3, 180, plus 5. Let's go ahead and do the 16 times 9 now. It's going to give me negative 144. Negative 144 plus 180 plus 5. 185 minus 144 is 41, which is the solution, which no surprise matches what they've said. That means the baseball launched from a 5-meter platform at 60 meters per second after 3 seconds is going to be 41 meters in the air.